We'll get started here in just a couple minutes as everybody gets brought. Please bear with us while everybody gets called in. We'll start about 2 or 3 minutes after the top of the hour. Okay, we'll go ahead and get rolling here. So good morning, good afternoon, good evening, everyone. And welcome to our ASABE member hour entitled A Century of Tractor Testing. I'm Chuck Roth, and I'll be your host today. As a background, ASABE member hours were started a few years ago as a mechanism for our members to learn, connect, and grow. So those are our big objectives here today. We'll get going here in just a minute, but a few ground rules. So for today's hour, I'd like to keep your audio on mute during the presentation. And if you have questions, you can either remember them and hold them till the end. We'll be opening it up for verbal questions, or you can drop them in the chat and we'll cover those as well during that time towards the end. This meeting is going to be recorded and will be available for viewing later on YouTube via the ASABE channel. Today, we're going to be hearing from Dr. Roger Hoy. Dr. Hoy graduated from the University of Georgia with his bachelor's and followed that with an MS and PhD from NC State, all in agricultural engineering. After that, he joined Danaher for 10 years before moving to John Deere, where he was a staff engineer working on tractors for 7 years. In 2006, he saw the light, came back to the academic world, but this time to the University of Nebraska-Lincoln as a professor and leader of the Nebraska Tractor Test Lab. Outside of work, Dr. Hoy has been a key ASABE member, serving in many capacities, most recently as a trustee. He also cemented his ASABE legacy by becoming a fellow in the organization in 2015. Along the way, he's published 20 papers, including a distinguished lecture that's part of the ASABE AETC series. Please join me in welcoming Dr. Hoy. And the topic of the Nebraska Tractor Test Lab will probably focus on a history and what's coming up in the future. Dr. Hoy, it's yours.
Well, thanks very much, Chuck. This is going to be a little more lighthearted, and it's going to be heavily focused on a history of the Tractor Test Lab instead of maybe so much what's going on today or what's coming in the future. Sort of in preparation for our event this summer at the summer meeting. So I want to remind everybody on the call that we are having an event at the Tractor Test Lab, open to ASABE members or Omaha attendees. That'll be on the Saturday before the meeting starts from 4 to 8 p.m. Now, I looked into registration for this event. And if you just go through the ASABE registration process, the only thing you see is Technical Tour T2, which is an option for a lot of people. It's $70 for the event, which includes bus transportation to and from Omaha for it. If, however, you're driving your own car, there is another option that's only $30, and you will find that not in the meeting registration, but in the meeting description, and it's listed as Tour A4. So that will take you to a University of Nebraska registration site, and it's a little bit cheaper. But I'll give you a hint about some of the things you'll see here in the rest of this presentation. So tractor testing actually began up in Canada, in Winnipeg. And in the early days of the 20th century, tractors were beginning to appear. They weren't yet called tractions, they were called traction engines. Previous to traction engines, there was a number of internal combustion engines that were sold to farmers that were on four-wheel dollies that could be rolled around and power a threshing machine with a flat belt drive or a irrigation well and so forth. But I think 1897 was the first real internal combustion tractor, and they were starting to appear in the first decade. So the early agricultural engineers felt that they needed to evaluate these machines and provide information for farmers. So they created an event called the Winnipeg Plowing Contest. And there were tractors pulling plows, there were animals pulling plows, and they created some of the early measurement systems for tractor testing. So an interesting fellow that was involved in this was Leon Chase. I think he was maybe the sixth president of ASABE at the time, but he was a UNL graduate from 1904, and he eventually became our first chairman of the new agricultural engineering department when that was formed a few years later. So Dr. Chase served as a judge in the event in all years, and he actually directed the event in 1913. Well, 1914 rolls around, and Canada, being part of the British Empire, gets engaged in World War I. So Chase moved the event to Fremont, Nebraska. And there's data that suggests it occurred.
Are you flipping? Were you intending to flip slides?
Oh, am I not flipping sides?
They're not flipping through.
Okay.
Oh, shoot. Okay. Yep. Sorry about
That's
that.
the celebration. That's Dr. Chase. I got to use my mouse, apparently. Sorry.
You're good now. Thanks.
So this Fremont trial was held for several years. I actually found some data from 1917 where 90 different tractors were tested and really developed the early equipment techniques for tractor testing. So this is a picture of a 1916 Ford Model B. It never was presented for test at the Nebraska Tractor Test Lab. But this particular tractor was bought by a farmer named Wilmot Crozier. It's not a Henry Ford tractor. It is a Minneapolis Ford, and the story goes two guys developed this tractor and hired somebody on their board of directors that had a last name of Ford, and they called themselves the Ford Tractor Company. So Henry Ford, consequently, a few years later, when he introduced Ford tractors, couldn't use his own name, so he called them Ford and Sons, or Fordsons, which many of you will probably remember that name. Anyhow, this is the front of the tractor we're looking at. There's just a little steering wheel on the back. It didn't really work. It broke down a lot. He couldn't get parts for it. There was no dealer, no power. So he convinced the company to exchange the 1916 model for a 1917 model, but since they had not changed the design whatsoever, he got the same results. So his third tractor was a Little Bull that had no durability. And the Little Bull was advertised as the tractor sensation, does the work of 5 good horses and sells for the price of 2 poor ones, is light and can travel anywhere, which was a total fabrication, as many buyers discovered. So the fourth tractor Crozier bought was a Rumley oil pull, and here's one actually harvesting wheat. It gave him no trouble at all. It performed exactly as advertised. So Crozier asked if, one manufacturer can build a dependable tractor. Why cannot all tractors be dependable? Well, he found himself elected to the Nebraska legislature. Now, in 1919, when he was elected, we did not have a unicameral yet. So we still had elected congressmen and senators, and he was a congressman. So he teamed up with State Senator Charles Warner, and they wrote the Nebraska Tractor Test Bill, which passed the legislature in 1919. Only one dissenting vote. And Dr. Chase provided all of the technical details to Warner and Crozier from Washington, D.C., where I think he was a lieutenant colonel in the Army during World War I. So the original tractor test law requirements, you see Dr. Chase's mark right here on the first one, that the University of Nebraska's Agricultural Engineering Department was responsible for testing advertised claims. You had to have a parts warehouse in Nebraska. You had to have at least one repair facility in the state. And if you performed as advertised and had this other support, you could get a sales permit that allowed you to sell that model of tractor in Nebraska. And it also created a board of engineers under control of the University of Nebraska to develop testing procedures and review and approve test results. So a temporary building was erected at the end of 1919 to serve as the Tractor Test Lab. And this is what that building looked like in 1920. It served as the Tractor Test Lab till 1981 when we moved into our current facilities. And today the building still exists and houses the Lester F. Larson Tractor Test and Power Museum. And we had a chancellor that was hoping to put a parking deck where this building was and thought it was unsightly and wanted to tear it down. So another of our former alumni and department heads and ASABE presidents, Bill Splinter, was very active to get it designated as a historic landmark of agricultural engineering in 1980, which protected the building. So my title today is Director of the Tractor Test Lab. We started off with engineers in charge. So the first guy to run this place was Claude Shedd. And he went on to have a wonderful career with water and grain storage and handling. He was recruited by Chase to get things set up and going because he'd been one of Chase's assistants at the Fremont trials, but this was really not what his flavor was. So he put the lab in commission and he tested the first 44 tractors. He left about halfway through the first test season when we had 65 tractors presented for test. And one of his chief assistants, Fred Novak, served the rest of 1920 and 21, testing about another 34 or so tractors. In 1921, we moved to Elmer Brackett. And in 1925, he became the department head of agricultural engineering, so he left the job. A little interesting fact about Elmer Brackett was he had a son, also named Elmer Brackett, who was a Marine aviation general. I think served through Vietnam, but he was a light colonel in the Marine Corps during World War II. And for those of you that might remember that show, Black Sheep Squadron, that sort of fictionalized Greg Boyington, a Marine fighter race, the Colonel Lard that's depicted in that show was real life guy, was actually Elmer Brackett's son. So in 1926, we hired what we thought would be the first full-time director, a gentleman named Lou Wallace. However, He developed stomach ulcers during 1929 testing, and he went in for an operation and died on the operating table. So Shedd and Brackett had long distinguished careers and were named ASABE fellows in their time. So early testing, we were interested in drawbar power, how hard the tractor could pull and how fast it could go. All of these early tractors had the flat belt drive remaining from the original motors on dollies, so we called that belt horsepower. And I suppose the other thing that we measured on everything was fuel consumption. And so drawbar power and fuel consumption we test today. Of course, nobody builds flat belt drives on tractors anymore. And I guess since the earliest days, ag engineering students have been employed at the Nebraska Tractor Test Lab to do much of the work. Some days it might be they're doing about 80% of what goes on. So test number one, which is where we kind of date our history from, was in April of 1920. And it was a John Deere Boy Waterloo Model N. So Deere had bought the Waterloo gas engine traction company in 1917. They had not yet designed a new tractor, so they were still selling under the Waterloo Boy name. And it 25 belt horsepower and 15 drawbar horsepower. So you sort of question, if Crozier had bought a Waterloo Boy in 1916, would we have a Nebraska Tractor Test Lab today? And the answer is probably not, because both Missouri and North Dakota were considering similar legislation, and they dropped their efforts when Nebraska acted first. But I might be coming to you from North Dakota or Missouri if he hadn't bought that Ford tractor in 1916. So this is an early drawbar test, one of the very first. The tractor under test is on the left. There is a hydraulic cylinder that's connected to the load unit on the right. And by knowing the area of that cylinder and knowing the pressure in the cylinder, you could determine how much force was being applied. So we quickly settled in 1921 or so on this little car right here, which was nothing but instrumentation. And it was connected by that same hydraulic cylinder, the tractor on test, which is this Cletrac. And various load units were employed to provide resistance to the pull. So we have an oil pump unit here on the back. I'll show that in the next picture. And another tractor that's braking somehow or another to provide load. And so here is that same instrumentation car directly coupled to the oil pump unit. This was just a ground-driven hydraulic pump that was pumped through a restrictor valve, and then it had a fan running off the wheels too to try to cool the hydraulic oil. And you see the same hydraulic cylinder here between the tractor under test and this instrumentation car. Now, the early belt power tests are somewhat unknown. We don't have any record of ever using a Prony brake dynamometer, but we see one here with the lab in the background from the 1920s era, so that perhaps was used. This was a pulley that's attached to the flat belt from the tractor. It's on an axle to this other pulley that has a band clamp on it that was tightened to apply load. But at some point, we got an electric resistance dynamometer, probably pretty early. So after Lew Wallace died, Carlton Zink served as the engineer in charge from 1930 to 1941. And he was the first really long-term stable head of the tractor lab. After the lab closed up during World War II, and by the end of World War II, Zink was working for Deere. I think he is particularly famous for his advocacy for Ropson tractors later in his career, but he is also an ASABE fellow. So he was around for, a little over 200 tests that occurred up to World War II. Here's a better picture of that dynamometer. You see the mechanical scale here that's actually on a linkage from the case of this dynamometer. So by knowing the force it took this case to keep from rotating and knowing the distance from where that force measurement was to the center of the shaft, you could get the torque that was being produced. And you see these big resistor banks up here. These would be activated in whatever order was necessary to apply load. So really this dynamometer was an electrical generator dissipating its load through the resistor banks. And if you come this summer and you check out the ceiling above these resistor banks, which are still mounted in the museum, you'll notice there's some charged ceiling joist up there just from the heat that could be produced. Kind of the other side of the wall, tractor on test. You notice this chain arrangement. We actually had lugs in the floor so we could tension the belt properly on the tractor. So that instrumentation car was replaced. I'm not really sure about 1937. It existed then, but I've got other records that say it wasn't used till 1940. But Charlie Adams was an interesting individual that worked at the Tractor Test Lab, and he came up with this design. So here you see a load unit, the nose of it on the left attached to the back, and up here on the right, you see, I think, our 10-inch hydraulic cylinder, 10-inch diameter cylinder. And the chain is connected to the tractor under test, which really isn't in the picture. And this is actually a 1956 picture of that unit. So sitting inside that, you had two pressure gauges that were measuring the force of the cylinder. You had tachometers over here that were giving you things like engine speed and wheel slip counters and so on. This car, of course, was used in some form from when it was put in commission in the late 30s right through 2002. So there's quite a bit of modification. There's a strip chart recorder here that's recording drawbar pull and time. That obviously was a later addition. So I'm guessing this picture was taken sometime perhaps in the early 70s. Just a picture of it in use. We're testing this crawler tractor. There's a whole train of load units behind it going around a dirt track here. And fuel consumption was a big deal. It was a lot harder to measure. So this tank that's sitting on this scale is a day tank for supplying the tractor. So it would be weighed very precisely at the beginning of the day, and then the tractor would go do something for anywhere from 1 hour to 10 hours, and it would be weighed again. And the difference, of course, in the weights would be the fuel consumed for whatever the task the tractor was doing. And we had to deal with a lot of different fuel types. So in 1920, we had kerosene and we had gasoline. We had some distillate fuels that showed up occasionally from coal. Starting in the 1930s, diesel started to become prevalent. And of course, that's surpassed all other fuels today, primarily. 1934 was interesting. We started testing pneumatic tires on tractors, and it was on an Alice Chalmers WC. But some of the original research about rubber tires versus steel lugs were conducted by Lloyd Hurlbut as a grad student under the supervision of Chauncey Smith in 1932 and 1933. So Alice Chalmers kind of jumped on that work. Now, Hurlbut, he went on to eventually become the department head of ag engineering in the 50s and early 60s. And Chauncey Smith was involved with tractor testing right from the beginning until he retired in the mid 50s. He was a member of the Tractor Test Board. And the changeover was so quick that the last tractor with steel wheels was tested in 1937. And this is really not completely fair characterization, because between 34 and 37, manufacturers were generally bringing both wheeled rubber tire tractors and the same tractor with steel wheels and testing them both. So that John Deere G did have a rubber tire option, but the changeover was literally in a 3-year period between 34 and 37 to rubber tires. So the lab shut down during World War II, and of course, the farming industry was primarily converted to making necessary war production. So there weren't new tractors to test. So after World War II, Lester Larson, who was a former department graduate, was pried loose from South Dakota State to come back to Lincoln and open things back up. And he served as the engineer in charge for 30 years, from 46 to 1975, and he tested 800 tractors. He also is an ASABE fellow, and he was the longest serving head of the Tractor Test Lab. So just some interesting things in his tenure. This was the lightest tractor ever tested. It was a 1 belt horsepower, 0.7 horsepower, I think some form of rototiller. We built a little ledge on the front of the test car for him. This is a Dodge Power Wagon. So at the end of World War II, Willie's Jeep was looking for a market for all these Jeeps they'd been selling to the military. So they put a PTO on the back of the Jeeps and called them a tractor. So Dodge got into the act too, and this was equipped with a PTO. So it was a tractor that we had to test. Heaviest tractor we ever tested occurred in 1956. It was a 66,000 pound crawler tractor. So apparently this was a little too much for the load car, so they put the hydraulic cylinder in between this load unit and there, just let the instrumentation car back farther in the chain to get enough traction. It pulled about 56,000 pounds. Couple big things happened in 56. And one of them was we changed from using a dirt track to a concrete track. So we got out of testing steel tracked vehicles entirely in 56 by another change, and concrete provided a more consistent surface. So with the dirt track, trying to achieve consistency was always difficult. You know, you'd be chopping and watering and packing over and over again, but the conditions of the track would change during the day. And so with concrete, that took a lot of that variability out. The other big change that happened in 56 was we achieved a modern definition of an agricultural tractor that excluded construction and lawn and guard equipment. So back in 1920, there really wasn't much distinction between the ag industry and the construction industry. But by 1956, it was more recognizable, and we realized the purpose of the law was to protect farmers engaged in agriculture. So getting rid of those steel track tractors allowed us to do the concrete track. This is that Zaz, or that Adams test car, now known as the Larson Zaz Carlisle test car. Some of you may know Frank Zaz. He was instrumental in doing this. So it was put under an Oliver chassis, which also allowed it to do some braking. So this Oliver chassis was good for about 10,000 pounds of drawbar load. The fuel tank set on top is what's supplying fuel for the tractor under test. And you still see the hydraulic cylinder. This was a 75-inch one. We had to get bigger as tractors got bigger. And that's probably an 8560 Deere load unit attached on the back that you can't really see. And this was actually used until 2002. This is actually the third Oliver tractor that was under it, the first in 1960. First sound test was on a John Deere 7020 in April of 1971, 97 decibels at the operator ear. This was some of the original sound equipment that was actually used for that test. So we're guided a lot of times by farmers and what they told us these tractors are kind of noisy. Can you do something about it? So our response to that was we're going to start measuring noise, and the manufacturers were not completely enthusiastic when we mentioned it. But a real funny thing happened. We published these sound numbers, and of course, everybody's marketing department looked at this and they started writing specs for the design engineers to be quieter than the competition, and sound progressively decreased. Today in a cab equipped tractor, we might be as low as 67 or 68 decibels at the operator ear. I don't think we can claim full credit for that, but I think we did maybe act as a catalyst that caused it to happen 12 or 15 years before it otherwise might have. So when Larson retired, Lou Leviticus took over the lab, and he served for about 20 years. He specifically retired on January 1st of 1997, so he could claim 1997, but he was around for about 600 or 550 tests or so. He was a fellow that was very confrontational. He'd grown up as a Jew in Nazi Germany and spent most of the war with the resistance. Most of the time they were protecting him. He wasn't actually used in the fighting, but he did apparently kill a couple of German soldiers right at the end of the war before he could be found. So he enjoyed conflict, which wasn't necessarily the best of all things for the lab, but some of the things in his time. Here's a big Bud 421 drawbar horsepower. Our test track was only 15 foot wide, so we had to move out to the Lincoln Airport and borrow some of their ramp space to create a track that was wide enough to test this tractor. I mentioned we've gone pretty much all to diesel. Well, the last gas tractor tested was an IH 284, which was a very small tractor. That was in 1978. It's been all diesel ever since. This is our current facility. So this is Splinter Labs, kind of, what would that be? This is the northwest corner of the building. So we have the west end of this building, two overhead doors, a matching one on the opposite side to get big equipment in and out. Our farmers told us that some of their tractors wouldn't pick up implements that they ought to be able to based on what manufacturer's stated hitch capacity was. So we started a hitch lift test in 1984. So what you see here is the force that can be exerted 2 feet behind the hitch balls, which is some estimation of the center of gravity for a lifted unit. I'm not totally sure that's still accurate today, but that's what we do. The other hitch test we do right at the hitch balls. And so what we have here is a forklift mast laid sideways with the cylinder, and we provide hydraulic power to this cylinder to work against the tractor hydraulics, and we determine what can be held throughout the hitch lift range. That little 120 horsepower electric generator dynamometer we used in the 20s and 30s. We're now using a 1200 horsepower eddy current dynamometer. Of course, we don't have to do the scales anymore. Somebody's invented load cells in that time, so nobody has to be up close and personal with it during testing. And of course, machine hydraulics probably first appeared in the late 1950s, but those systems were primarily to power something like a front end loader. By the 1980s, hydraulic power was becoming a common source of implement power. So in 1988, we started testing hydraulic power on a tractor. So, we have pressure transducers at the remote pairs on both the supply and return, and a flow meter to measure flow, and a restrictor valve to apply load. So when Lou retired, Leonard Bashford became the director of the lab. And the title was actually changed from chief engineer to director. And Leonard had been the chairman of the Tractor Test Board and a board member for about 30 years before he took this on. And he served from 97 to 06 for about 150 something tests. Leonard was a pure ag engineer. He always referred to himself as an endangered species, and I understand that feeling completely in the modern world today. Let's see some other interesting things. Highest draw power ever tested was this Case IH 620 quad track, over 60,000 pounds of drawbar pull and 500, almost 562 drawbar horsepower. That's still our record. Highest PTO power was done more recently in 2240 in 21, I think this was, but 598 horsepower at rated engine speed and 600 and almost 605 horsepower at maximum power. Most fuel efficient ever, I believe, is a John Deere 8R 410. And that's at, I can't really see the top of my slide here, but 19 point something horsepower hours per gallon. So that's a normalizing fuel economy measure. Horsepower hours would be energy, mechanical energy delivered divided by gallons of fuel used. So this is one way of comparing various tractors of different, slightly different power levels. So cost of testing. 1920, it was free. And the university figured out right away that was not a winning proposition. So they went back to the legislature and had the law modified so they could charge reasonable fees. 1921, it was $250 a model, and it's gone up over time. Today, it would be typically for a full test about $25,000 per model. We also have a limited test for tractors under 100 horsepower that's about a little less than half that, where we exclude the drawbar testing. And the asterisk is the actual cost is determined by power achieved and time on test. So, these are typical numbers, not precise. And significant legislative changes. I think I've talked about the first three. 1967, the Department of Agriculture became the enforcement agency instead of the State Railway Commission. So the Tractor Test Lab does no enforcement of the tractor test law. If there is a claim that's not met or somebody's selling an untested tractor, that's the Department of Agriculture's responsibility to enforce. Large change came in 1986 when we changed the law to also recognize OECD test codes and allow the NTTL to participate in OECD. So the performance code for OECD was derived from the Nebraska Tractor Test. And I would say that today, probably 85 to 90% of what's in that code was created at Nebraska. See, 89, and we're active in that. We keep the stuff we want. 1989, we removed the drawbar test requirement for tractors under 100 horsepower. And then in 2012, we actually made testing under 100 horsepower optional. So typically a professional farmer does not pay sales tax on machinery he purchases. He has to pay that sales tax if he buys a non-tested tractor under 100 horsepower. And I guess I'm going to conclude by saying we measure everyone with the same yardstick. So this is our 75-inch hydraulic cylinder. We actually have moved up to load cells now, but it's a nice picture. I don't think anybody thought the tractor test facility would last very long. I think the original thought back in 1919 was we'd operate for a few years, get all the fly-by-night manufacturers out of business, and then it wouldn't be necessary to have us anymore. But what happened was as soon as we started publishing test results, the reputable manufacturers started competing with each other on those results. They started using the results in their advertising. And that really still goes on today. So it's there's a legal requirement to test, but I think it's more a marketing business requirement that's kept us in business. And of course, we've not favored anybody here at Test. We want everybody's tractor to have its best days while it's being tested, but we don't fudge the numbers and we don't favor anybody. And of course, I think if we hadn't been doing that, we would not have had the credibility to last as long as we have. So I guess, Chuck, at this point, maybe I'll shut up and take some questions if anybody has them, and we can go from there.
Yeah, thank you very much, Roger. I really appreciate the presentation and all the information. There were a few questions that came across, but I think I covered most of those. One that came to my mind is, can you kind of quickly comment on the involvement that you have in other testing? Specifically comes to mind the ROP standard.
Oh, okay. Other things we do. So OECD codes also cover protective structure testing like ROPS and FOPS. And they are a past OECD test is one way of meeting the EU and countries that follow the EU model requirements for ROPS. So for a lot of manufacturers, especially here in the United States, asking us to be part of an OECD ROPS test is really helpful to them. So we don't actually have ROPS testing facilities here at Nebraska. And what we do is we go to wherever the ROPS testing facilities are. For some manufacturers, they may have their own. For others, we may go to an outside lab and do the work there. But we will conduct predominantly static ROPS test on agricultural tractor ROPS. We will do falling object protective structure testing too. That's often done in a cold room to show cold weather embrittlement resistance properties. Of course, that's very valid because you're dropping an object, a ball, steel ball on top of the cab, so you do have an impact type load. The cold weather embrittlement really doesn't work with the static test. That's usually met better by just using Sharpay resistant steels that have the cold weather embrittlement properties. Let's see, other things we do non-officially, we will test other types of machines where they fit our competencies or conduct other types of research. So, some examples of that: a few years ago, we actually had great support from John Deere, and we were looking to compare the fuel efficiency of a CVT equipped tractor with a power shift or step transmission. So, we really looked at three modes. We looked at the CVT just doing whatever it wanted to do. And we looked at the step transmission operated at full throttle and then operated with a higher gear and the throttle shifted back. And we weren't really looking at 100% loading, which isn't really field work. We were, I think, considering between 30 and 80% of maximum drawbar pull capabilities. And, so we found some interesting stuff. We actually found that the step transmission shifted up and throttled back was the most fuel efficient solution of all, but the CVT was certainly far better than just keeping the throttle wide open and stuck in a gear. So it really illustrated shifting up and throttling back. And some of the things we've seen occur in the market have been I think Deere provided us two tractors, and we switched tires between them and ballasted them, so we had the same front and rear axle weights. But I think it was a 16-speed power shift, and that really sounded pretty clunky shifting under load. But then a year or two later, we see this E23 transmission comes out that's got a lot of really close shift patterns in the field gear ranges that shift smoothly under load. So, that was pretty good. We did a tire track field study for Michelin where we took our load car and load units and a couple of tractors of the same model, one with tracks and one tired, out into an irrigated field one summer and compared ground compaction, fuel efficiency, drawbar pull, everything between the two tractors. That was kind of interesting. We found out that the wheeled tractor did better in all categories and all except the most extreme wet conditions, which I don't know. When we were out there doing it, I was thinking nobody in their right mind would be in a field this wet, but I suppose some of them would be. We test some other construction equipment from time to time, more as overflow work for other manufacturers. We've had motor graders through here. We've had steel track crawlers on dirt. We've had skid steer loaders. So, wherever somebody wants to do something and it doesn't interfere with official tractor testing and we're competent to do the work, we'll certainly help out as we can. That's probably more than you wanted, Chuck.
No, that's really good. In fact, I think you've sparked a few more questions here, so I'll start rolling through them. And if there is somebody that would like to also speak up when time allows, please feel free to ask that question as well. First question is, what is the ratio of track to wheel tire or wheel tractors that you see coming through the lab at this time?
I would say that the majority are wheeled because we test smaller models as well that don't necessarily have track options. But I will say that when we get into the bigger tractors like the large row crops and the four-wheel drives, I think we generally see everything the manufacturer offers. So you might not have tracked options for all power levels, but where they exist, those tractors come for test.
Sure. Thank you. Next question is ISO 789-10 the only ISO standard that's dual labeled ISO and OECD 789-10?
That might be at this point. I'm not entirely sure about ISO 5700 and 3463, which are the static and dynamics ROPS test. They may also still be dual labeled. They were at one point. We've been fighting to have the ISO series of ROPS and performance standards technically equivalent to the OECD test codes, but it's been a bear. The ISO timeframe for modifying standards does not match OECD, and it's difficult to keep up. It seems like every time we harmonize, we're only, as soon as it comes out, we find out, well, we're 2 years in arrears or something like that. So it's difficult.
Gotcha. Maury had a question. Has there been any tractors that, in your experience, that do not pass testing? Without naming brands, is there an estimate of percentage of tractors that don't meet their claims? And then also, how much time do you usually offer the manufacturer to adjust their unit?
Well, okay. So I would venture to guess that 15 or 20% of the tractors we test do not meet a claim. And we classify claims as major or minor. So for us, a major power claim would be not meeting your advertised power. And that's rare. I think it's happened like on 4 tractors since I've been with the lab since 2006. So when that happens, the tractor test law kicks in, and the manufacturer is required to come up with a plan that's approved by the Department of Agriculture to inform all owners of those tractors that might have purchased them on a temporary sales permit that the tractors do not perform as advertised, and here's what we're going to do to correct the tractors to perform as advertised or otherwise satisfy the customer. So that's kind of the lethal penalty. For the minor power claims, which might be, a very common one is not making a hydraulic power flow claim. And the way this one comes about most often is somebody in marketing that's writing the manual calls an engineer in hydraulics and asks what is the output of the hydraulic pump at rated engine speed, and they get a number. But we measure the flow rate at the remote valves at the back of the tractor. So the flow rate will always be less than what it is at the pump because you have restrictions for piping and valves and so on and so forth. So you just can't meet that claims. That's seen that happen periodically. With those sorts of things, if you look in our remarks section on the second page of our reports, we list claims that were not met. And for some reason, it seems like competitors pick up on that real fast as soon as we publish a report and the information gets out to their dealers. So it's a little bit of a black eye when a claim's not met. As far as adjustments to the tractor go, typically when we start with the tractor, most of the time we start with the PTO dynamometer because that's where the power claim is. And so we will allow the manufacturer whatever time he would like to have before we start the test to see what numbers we're getting, make adjustments if he's desired. Once he's happy, we have a form that the manufacturer and the Tractor Test Lab sign that basically starts the test. So at that point, the tractor is really in our custody. And we will allow the manufacturer to do anything to the tractor that is covered in the operator's manual. So if the operator manuals advises you to check and top off the oil at periodic intervals, he can do that. But if he has to go into the service manual for something, that becomes a repair. And there is another section on page 2 called repairs. And so if something had to be repaired during test, it will be noted there. And then, of course, at the conclusion of the test, we sign the tractor back off test and return the tractor to the manufacturer. So really, on that period while it's on test, anything that's not found in the operator's manual that has to occur to that tractor is a repair.
All right, thank you very much. There was another question that came through, I think I missed it, about testing electric vehicles, and I'm going to tie that one in with another question of what is the Nebraska Tractor Test Facility doing to look at electric vehicles or other low carbon fuel options such as renewable diesel, hydrogen, etc., as engine and tractor manufacturers are starting to transition or consider some of those options?
Well, with electric, I think there's 2 branches to that, and we're working on both of them. One would be a fully electric tractor. We're going to test our first one of those officially. It's not set in stone yet, but I believe it's going to occur this fall. And it's a company called Monarch located out in California. And our philosophy is that when testing an electric tractor, we should do it the same way as an internal combustion engine powered tractor. In other words, we're not really interested in how long the battery lasts. We're not interested in how long it takes to charge, because we feel if those things are obstacles, they're not going to be commercially viable anyway. So the only real difference we're going to make is instead of measuring fuel flow rate, we're going to measure electrical energy being consumed by the batteries in the various tasks. And we'll publish it in that form. We're trying to talk OECD into the same thing. They're farther behind than we are, and we haven't managed that yet. The second electric branch is going to be an internally combustion powered tractor that offboards electric power to implements. And there we're working on some sort of motor that can be powered by the tractor electric power that can be connected probably to a retarding device, a dynamometer or a Telma driveline retarder or something like that that will allow us to apply a load to verify those claims. And in this case, we're kind of looking at this the same way we would like hydraulic power. We're trying to say, okay, this is a legitimate power outlet for a farmer. So let's find out what sort of power actually is available to him in that format.
And kind of the second half of that question, or another piece of it, was lower or alternative fuel options. Any changes to the testing there?
Well, I think with alternative fuels, part of our test procedure, it's found in OECD codes, is we are supposed to use the commonly available fuel for the tractor. So if farmers are using an alternative to diesel, like soy diesel or something like that, then we would feel compelled to use the same thing. Right now in Nebraska, it's straight number 2 diesel. As far as alternative fuels other than diesel or diesel type products, we've tested propane in the past. We've tested natural gas in the past. We would follow the same sort of procedure I outlined with the electric power, where we would want to provide fuel properties and fuel consumption at various operating points like we do today in our test. And if anybody's thinking of something like that that's on the call that they want to have tested, please get hold of me, because we're still learning about all the technology too. And our testing always seems to be in arrears a little bit to the technology, but we will react to wherever the technology goes.
All right. There are a few other questions that have come in here. I would like to mention just a couple of closing comments. Then we can try to answer those questions. Roger, if you've still got a few minutes, I know I do, to hang on.
Yeah.
Okay. Just a couple of closing comments, and then we'll jump back to the questions. I just want to cover a couple things. First off, thanks for your participation today. Special thanks to Dr. Hoy and Sarah Rodriguez from ASABE staff. Our next ASABE member hour is on April 11th. That's 1 week from today. We will be starting at noon Eastern, so an hour earlier than today. And we'll have ASABE President Keith Tinsey, and he'll be sharing about potato production and the supply chain, potato supply chain. Following that, starting April 27th, running through May and June, will be several sessions on the circular bioeconomy systems. So look for an email on that as well. So thanks again for your participation today. We'll jump back into questions here real quick, and keep going down that road as we finish up. Let's see here. I think, Joan had a question. Do you foresee any partnerships with Iowa State's full vehicle chassis dyno facility?
Anything's possible in the future. We had looked back in the 80s at doing a chassis dynamometer. It was actually a treadmill type, but then manufacturers decided they were going to start having front wheel assist and front wheel drive that kind of put the kibosh on that. But another way that's been suggested we might go is to take the tires out of things completely and just use axle brakes and load that hydraulically. So it hasn't been a demand for that yet, but if there is, we would certainly look at all of our options.
Sure. All right. And then I think the next question was answered, but there was another question of, is there any parallel facility that tests construction equipment within the US or globally?
Not to my knowledge.
Another question, how easy is it to get testing facilities in other countries with the aim of unifying testing across OECD?
Well, we're an OECD country, or even a non-OECD country, has a tractor manufacturer, it's pretty easy. For example, Brazil is trying to join the codes right now, and they're trying to get a test station up and running that will eventually be an OECD tractor testing station. Where there's not tractor manufacturing, it's really difficult to do that. So generally you see OECD test stations predominantly in the countries around the world where tractor manufacturing exists.
All right. Let's see, another question. Are the test methods under Nebraska legislation still, or are they totally independent?
The Nebraska law allows us to use either ASAE, SAE, or OECD tractor test codes. And the test stations in the industry have moved predominantly to OECD tractor test codes, and a lot of those old performance standards have been withdrawn. But the Tractor Test Board is still empowered under the law to develop new tractor test procedures. So a perfect example would be maybe this electric tractor that's going to be presented for test this fall. That's not covered in OECD yet. So the Tractor Test Board will ultimately approve the test procedures we use to test that tractor. And that will be what we use until OECD comes around and gives us something better.
Okay. Actually, that's a really good tail into the next question, and that is, are there any thoughts on how rated power would be determined on an all-electric tractor?
That's a good question. I don't know the answer to that, but I will say that our philosophy is to document the power that's available to the farmer. So we might instead think about power at standard PTO speed, something like that. RES is for the manufacturer to designate anyway, rated engine speed.
Okay.
So, I guess we'd have to see how they want to designate that, but you don't actually have this engine running at rated engine speed on an all electric tractor anymore. So, the other reason for testing rated engine speed is that's traditionally where the PTO power claim is most often made. So we may be verifying PTO power standard PTO speed instead of rated engine speed with an electric tractor.
Sure. Okay. And I think there's one more yet. Is it possible to get test duty cycles for tractors from the Nebraska Tractor Test Lab website?
I don't think so. Well, let me rephrase that. When you look at, say, PTO power columns, and you see power at rated engine speed, if you read OECD code 2, which is publicly available, if you just go to oecd.org and search for tractor test codes, you can download it. A lot of that data is presented in the tractor test report. So it will tell you exactly what the rated engine speed, max power, partial power numbers, and so on mean and how they were collected. For the drawbar work, the numbers that appear in the test report are typically an average of at least 4 different runs at the same power condition. So our test track is laid out east-west, and we always average at least 2 east-facing runs with 2 west-facing runs. So any effect of wind velocity is canceled out by doing that averaging. But you can also look at OECD code and see what's required. So for us, that's 500 feet of good data in each run. It's averaged with at least 3 others.
Okay, I think that answered most of the questions in the chat. Kind of open it up to everyone now. If anybody has any further questions, please don't hesitate to ask. All right, well, thank you again, everyone, for calling in. You know what? I think somebody did have a couple of questions. How many full-time engineers and how many students are typically on staff there?
Well, at present, I have 2 full-time engineers, and my time, half of my time is budgeted to the Tractor Lab. And I have about 25 students that work 10 to 12 hours a week around their class schedules at the lab.
Perfect. Thank you. And thanks for Noah for that reminder, that question. Any others?
One
Well,
last
yeah.
question there, Roger.
Sure.
Is the museum and lab open to anybody that wants to come swing by and visit?
Yeah. The museum normally is open Tuesdays through Saturdays. And the Tractor Test Lab is normally open from about 7 to 4 Monday through Friday. So if you want to catch both, coming on a Tuesday through Friday is your best deal. But if you show up at the Tractor Lab, announced or unannounced, we'll give you the nickel tour of the place.
Awesome. Anything else before we all jump off? All right. Well, thanks again, everyone, for calling in. Really appreciate just everybody who was here and Roger, the presentation. Looking forward to being able to see it all in person again for some of us, but some of us, I'm sure it'll be the first time here this summer as part of international meeting. So again, there's a celebration of 100 years of tractor testing, actually a little over 100 years now, right, Roger? Post-COVID, but that's coming up this summer as part of the international meeting. You can find that on ASABE's website or get registered there for asabemeetings.org, I think is the website. If you do a search for, let's see, ASABE meetings, should be there.
Yeah, and right now, if you're just registering for the meeting, you won't see that $30 drive your own option. You've got to go outside of the meeting registration into the description of events to find the link that lets you register that way. So trying to get ASAB to fix this, but I just noticed it yesterday. So that is an option for people that want to provide their own transportation.
Perfect. Thank you very much. And I look forward to seeing everybody there.
Thank you.